Hi everyone, welcome to another edition of 4-Minute Wrap-Up. I'm Rohit and I will talk about the stable matching problem and a new form of strategic behavior in this problem called accomplice manipulation. In the stable matching problem, we are given two sets of agents, commonly referred to as men and women. Each agent has a preference ranking over the agents on the other side. For example, man M1 thinks that his rank 1 or favorite woman is W2, his second favorite is W1, and his third favorite is W3. The goal is to pair up or match the agents in a way that is stable. This means that there should not be a blocking pair of agents. For example, the blue matching is not stable because there is a man-woman pair M1, W2 who prefer each other over their assigned partners. We want to find a matching that does not have any such dissatisfied pair. So, does a stable matching always exist? Turns out it does. In fact, there is an elegant algorithm that always finds a stable matching called the deferred acceptance algorithm due to Gale and Shaping. Here's how it works. In each round, every unmatched man is going to propose to his favorite woman who hasn't rejected him yet. And any woman who receives multiple proposals is going to tentatively hold on to her favorite one and reject the rest. The algorithm alternates between proposals and rejections, like so, until everyone is tentatively matched, and that's when it stops. The final matching, quite magically, is guaranteed to be stable. The deferred acceptance or DA algorithm has many practical applications. For example, it is used to match students with schools, doctors with hospitals, refugees with host countries, and even organ donors with patients. In fact, the DA algorithm is so important that it had played a central role in the Nobel Prize in Economics in 2012. Okay, so the DA algorithm is amazing, but it also has a weakness, which is that it is vulnerable to strategic misreporting of preferences or manipulation. For example, for the instance shown on the left, the woman W1 gets matched to her second choice when she reports truthfully. But if she misreports her preferences by switching her second and third choices, like so, then she manages to get her top choice. I'm going to call this kind of strategic behavior self-manipulation because the agent who wants to improve, the woman W1, is doing the misreporting herself. Now, self-manipulation is bad enough, but my goal is to highlight a different and arguably more serious weakness of DA called accomplice manipulation. Here, once again, there is an agent who wants to improve, the woman W1, but this time she remains truthful herself. Rather, she gets help from an accomplice, the man M3, who misreports his preferences in order to help the woman W1. Turns out accomplice manipulation can be more helpful than self-manipulation. Indeed, in this instance, the best partner that W1 can get under self-manipulation is her second choice. Whereas under accomplice manipulation, if M3 misreports, then she gets her top choice, which is strictly better. And this idea motivated a joint work with Hadi Hosseini from Penn State and Fatima Umar from Rochester, where we explore accomplice manipulation in more detail. Basically, we ask two questions. First, is accomplice manipulation usually more helpful than self-manipulation? Turns out that in simulated data, accomplice manipulation significantly outperforms self-manipulation. This suggests that the example I showed you before wasn't a one-off. Accomplice manipulation really is a serious concern. The second question we ask is whether there is a fast, i.e. a polynomial time algorithm for the accomplice to figure out his best strategy. And again, the answer turns out to be yes. This result uses a nice structural observation, which is that the optimal misreport for the accomplice can be derived from his true list simply by promoting a specific agent, in this case W5, above his DA partner. Okay, let me wrap up this 4-minute wrap-up by saying that if you found accomplice manipulation interesting, you might also be interested in our follow-up work with the same set of authors, where we look at manipulation by a team of agents. Thank you for listening and get in touch if you have any questions.